All right, so for this first regions video, we're going to start with the January 2024 regions. We're going to start with question 32 on page 249, okay? All right, so let's take a look at it. So Trish is a surveyor who was asked to estimate the distance across a pond. She stands at point C, 85 meters from point D, and locates points A and B on either side of the pond such that AD and B are collinear. Now Trish approximates the measure of angle DCB to be 35, so this one's 35, and the measure of angle ACD to be 75. Now we want to determine and state the distance across the pond to the nearest meter. Okay. Now the length of AB is equal to AD plus DB. Okay. Now as you can see, this is a right angle, this is a right angle. So we have two separate right triangles here. However, we are going to have to break them up a little bit. So we're going to have to find the length of AD first, and then we're going to find the length of DB. All right, so here's ADC. So this angle is 75, this is 85, and this is my right angle. Okay. So we're going to have to use SOHCAHTOA here. So let's first find length of AD. So here is my person. So this is my opposite, this is my hypotenuse, this is my adjacent. So I am finding the length of AD, and I'm given my adjacent, so I'm going to be using tangent, okay? So tangent of 75, tangent is opposite over adjacent, so x over 85. Okay, so cross multiply, so we get 85 times the tangent of 75 is equal to x. All right, so let's now find the length of DB. Okay, so we're going to call this y because we called this x. So here's my person again. So this is my opposite, adjacent, hypotenuse. So again, we're going to use tangent. So tangent of 35 is equal to y over 85. So let's cross multiply. So 85 times the tangent of 35 is equal to y. Okay. So as we talked about up here, AB is equal to AD plus the length of DB. So it's equal to x plus y. So to find the length of AB, we're going to do 85 tangent of 75 plus 85 times the tangent of 35. So let's figure out what that is equal to. So let's get our calculator. So we have, I need to change my mode. So I have 85 tangent of 75 plus 85 tangent of 35. So AB is equal to 376.7419594, and we want to round to the nearest meter, so AB is equal to 377 meters. Now, up until now, all we've done is practice. Now, guys, this is the regions, okay? I want you to start getting in this habit of writing down each step, writing down all your steps, writing down the full decimal you get in your calculator. That way, you leave no room for yourselves to make mistakes, okay? So get in the habit now. That way, when it comes time for the regions, we'll already be doing that. That's already part of what we're doing, okay? So I really want you guys to get into the habit of it. I'm going to stress that even more. All right, so now let's take a look at question 33, so this next one. Okay, so we have a candle in the shape of a right pyramid. Hold on. Each side of the square base, so we have a square base, measures 12 centimeters. The slant height of the pyramid measures 16 centimeters. Now we want to determine and state the volume of the candle to the nearest cubic centimeter. Now, first thing I want you guys to get in the habit of doing is kind of checking your units. Like, am I given in the question what I need to find in my answer? Does that make sense? So, I mean, as you've possibly seen a couple times, there's sometimes questions where we need to change our units to a specific thing before we find the volume. So I want you to kind of like think about that first in the question. Am I given in my question what I need to find in my answer? Now we are given centimeters here, and we want to find our volume to the nearest cubic centimeters. So we don't have to change anything, okay? Now the next thing I want to talk about is the slant height of the pyramid. Now our volume of our pyramid formula is 1/3 area of the base times the height. Okay, now the height, remember, is that vertical up and down from the height of the vertex all the way down straight through the middle. Okay? Now this slant height is the height of one of its sides. Now these are two different things. Okay? Slant height and actual height, two different things. So before we even come close to finding the volume, we need to find the height, the actual height of this pyramid. Now, as you guys can see, as I've been talking, I've been drawing this pyramid. I've been drawing this triangle. Now, as you can see, the height, remember the height is perpendicular to the opposite side, so it forms a right triangle here. Okay, so we're going to use Pythagorean theorem to find the height. Now, our radius, this part is half of the side, so this is 6. Okay, so to find the height, we're going to do 6, 16, we have the height. So we're going to do 6 squared plus, we're going to call it h squared just for the sake of this. Okay, so this is 36 plus h squared is equal to 16 squared is 256. So h squared is equal to 220. Square root, h is the square root of 20. Now, here's the thing. I always harp on you guys about not rounding too early. I'm going to just leave it as a radical for right now. That way I don't even get myself in danger of rounding too early or putting in the wrong decimal or whatever. I'm just going to leave this as a radical. Okay? So let's go ahead and plug it into my volume formula. So volume of pyramids, like I said, is 1/3 area of the base times the height. So volume is equal to 1/3. Now we have a square base, and a square base is, to find the area of a square, is length times width. And our height is the square root of 220. Okay. Now my sides of my base is 12. So 12 times 12 times the square root of 220. All right, so once you go ahead and put that in your calculator, you guys are going to end up with 711.9550548. Now, stop for a second. Once you write out the decimal, then look at what you are rounding to. So we are rounding to the nearest cubic centimeters, to the nearest whole number. So our volume is approximately 712, because this 9 rounds that up, centimeters cubed. Okay. Now there's usually a second part to these questions, so let's look at the second part. So the wax used to make the candle weighs 0.032 ounce per cubic centimeter. Determine and state the weight of the candle to the nearest ounce. Okay, so again, I would always check your units. So we want our answer in ounces, and we're given this weighs in ounces. So we don't have to do any other weird unit conversions. We can just go ahead and find the weight of this candle. Okay, so our volume is 712 cubic centimeters. Now, per 1 cubic centimeter, the wax weighs 0.032 ounces. Okay? Now, these cancel. So the way my unit conversion is set up, this tells me that I need to multiply these two things. So let's do 712 times 0.032. So that's going to equal this. Now, stop for a second. Now let's go back and figure out what we need to round to. So the nearest ounce. So the nearest whole number, so 23 ounces is my answer for this part. Okay. All right, so let's look at the next question. All right, so the next question is a proof. We haven't talked about a proof in a hot second, so let's kind of look at it and see what we have. So in this diagram of quadrilateral ABCD below, we are given that AB is congruent to CD, AB is parallel to CD. Segments CE and AF are drawn to diagonal BD such that BE is congruent to DF. We want to prove CE is congruent to AF. Okay, so we want to prove these two things congruent. Now, first and foremost, remember, when we do a proof, we want to start off by stating our givens. Okay, so first given is quadrilateral ABCD. And you actually have to write the word givens. Now, I don't want you guys to be lazy with this. I feel like a lot of us have gotten lazy. We don't want to get lazy when it comes to the regions. So please, please, please do yourself a favor and just take the extra 30 seconds to write each one of these out, okay? So second thing was given AB is congruent to CD. Now, I'm going to write this one in one line for a reason. Okay, and then we are given that BE is congruent to DF. All right, so let's take a look at what we have to prove. So we have to prove CE is congruent to AF. So remember, when we are proving two segments or two angles congruent, it's going to be CPCTC. So this is what we're going to be using to prove this. However, but before we can prove this, we have to prove two triangles congruent first, okay? Now, I'm taking a look at this diagram, and based off what we're given and what we have to prove, I'm thinking maybe we try to prove these two triangles congruent, okay? All right, so let's take a look at the first two given. So we are given quadrilateral ABCD, and AB is congruent to CD, and AB is parallel to CD. So before we move any further, you guys are probably looking at this diagram being like ABCD is a parallelogram. And yes, it is a parallelogram, because remember, one of the four ways we can prove a parallelogram, and why don't we take this second to remember those four ways? One of those ways is opposite sides are parallel, so both pairs of sides are parallel. Opposite sides are congruent. Diagonals bisect each other. And the same side is both parallel and congruent. So since we have a quadrilateral with both the same sides parallel and congruent, this is a parallelogram. However, before we go any further, we need to say that that's a parallelogram. Okay, so ABCD is a parallelogram. And our reasoning is if a quadrilateral is, if quadrilateral has the same pair of sides both congruent and parallel, then it is a parallelogram. Okay? So now that we've said it's a parallelogram, we can use the properties of a parallelogram to help us with our proof. Okay, so we've taken care of those two givens. So now let's look at the third one. BE is congruent to DF. So this little part is congruent to this part. So remember, we're trying to prove these two triangles congruent. Now we actually can use AB and CD as a side, right? Now to get this whole side, I'm thinking we want to get BF congruent to ED. We're going to need to use addition property. But remember, before we use addition property, we need to say that what we're adding to both things is congruent, right? We can only add equal parts to equal parts. So first thing we need to do is say that EF is congruent to EF, and this is by reflexive property. Okay, so now that I've said that, now I can go ahead and do my addition. So now I can say BE plus EF is congruent to DF plus EF, or, so once we add BE and EF, we get BF. And once I add DF and EF, I get DE. Okay, so that's going to give me another side. Now, I'm thinking we probably need an angle. So based on what we have so far, so we have this side is congruent to this side. We have this side congruent to this side. So I'm thinking that it might be easiest for us to get this angle congruent to that angle. We already know that these two lines are parallel, sides are parallel, right? So now we can say that angle ABE is congruent to angle CDE, because if two lines are parallel, then alternate interior angles are congruent. Okay, so we have an angle. So now let's kind of go over what theorem we're using. So we have a side, we have an angle, we have another side. So I'm thinking to prove that triangles ABF is congruent to triangles CDE, we're using side, angle, side. Okay, so now we can say, now that we've said that these two triangles are congruent, now we can say that CE is congruent to AF by CPC PC. Okay. Now, while you guys are probably finishing writing, I want to mention, do not be lazy with the notation. I've started to see, like, towards the end, you guys are being lazy with notation. Not putting a segment symbol up above the segment you're talking about, not putting an angle symbol, not putting a triangle symbol. Those all matter, okay? Please, please, please do not get lazy with that. All right, so that was question 34. So let's now talk about question 35. All right, so question 35. So quadrilateral math has vertices with coordinates MATH. Prove that quadrilateral MATH is a trapezoid. So before we do that, I'm going to first graph this. Now, there is a coordinate grid for you guys, well, back here, but there is one for the question, on the question. Now, just so I don't have to keep flipping back and forth, I'm just going to do on a separate sheet of paper, but on the regions, you guys will actually, you will have that for you, okay? So let's first plot this. So M is -1, 7, so -1, 1, 2, 3, 4, 5, 6, 7. A is 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. T is 2, negative 7, so 1, 2, 1, 2, 3, 4, 5, 6, 7. And H is negative 6, negative 3, so 1, 2, 3, 4, 5, 6, 1, 2, 3. Right. Alright, so let's draw on this trapezoid. Now, in order to know what direction you guys need to go in for coordinate proofs, you guys actually do need to know the definitions for what you're trying to prove. Okay, so let's talk about what a trapezoid is. A trapezoid is a quadrilateral that has at least one pair of parallel sides. Okay? So taking a look at this, now what I recommend you do, regardless, is show all sides or do the slope of all sides. Now looking at this, it's pretty obvious that MA should be parallel to TH, okay? So let's do the slopes of MA, and let's do the slopes of TH. Now, if they are parallel, their slopes are going to be equal. So MA, let's first find the slope of MA. So MA is 5 minus 7 over 3 minus negative 1. Now, I do want to take this time to mention you either need to find the slope algebraically. Actually, I lied. Do you guys see the statement? The use of the set of axes on the next page is optional. That means that we are not going to grade what you do on the graph. So we are only going to grade your algebraic work, what we do in the space below, okay? Now, if you choose to do so, if you were like, I did this on my graph, then you actually need to show on the graph, this is over 4, this is down 2. You know what I mean? You actually need to show that in the graph. I would always go the algebraic way just to be safe that it gets counted and that sort of thing. However, that is an option for you to do graphically, but just remember you need to show as much possible work in your graph that you show the slope. I would just be careful of the use of the set of the axes is optional, okay? So that means we're not necessarily grading that part. All right, so let's go back to its slope. So this is negative 2 over 4, so this is negative 1/2. So the slope of TH, so it's negative 3 minus negative 7 over negative 6 minus 2. So negative 3 minus negative 7 is 4 over negative 8, so you get negative 1/2. Okay, so as you can see, they have equal slopes, so they are parallel. Now remember, with coordinate proofs, you also need a statement summarizing your work, kind of concluding what you want to prove. So for this, we can say MATH is a trapezoid because MA is parallel to TH, and a trapezoid has at least one pair of parallel sides. Okay? Kind of maybe a suggestion is using your work to kind of explain, mathematically explain the definition. Okay, so including what we have here in the definition kind of helps summarize that up. All right. All right, so let's look at the next part. So the next part says state the coordinates of point Y such that point A is a midpoint of MY. Okay, so let's kind of look at our graph. So somewhere over here in this general direction is point Y. Now we don't know exactly where. However, we were told that A is the midpoint of this segment. Okay. Now I'm going to do it algebraically, and then I'm going to show you graphically. I'm going to show you algebraically because, again, we need to show like some sort of work. Now, the midpoint formula, remember, is x plus x divided by 2 over y plus y divided by 2. Now, if we add the x coordinate to m, which is -1, to the x coordinate of y, and we divide it by 2, we get the x coordinate of a, which is 3. Okay? So same thing with y. If we add the y coordinate of point n, which is 7, plus the y coordinate of point y, and we divide it by 2, we get the y coordinate of a, which is 5. Okay? So we have two equations set up here. What we're going to do is we're going to go through and we're just going to solve for x and y. So x, so take 2, we're going to multiply it by both sides, so -1 is equal to plus x is equal to 6 plus 1 plus 1. So x is equal to 7. Okay, this one, so multiply 2 both sides. So you get 7 plus y is equal to 2 times 5 is 10 minus 7 minus 7. So y is equal to 3. Okay, so my coordinate of y is 7, 3. We actually need to state that. Okay, so let's plot that. So 7, 6, 7, 1, 2, 3. Okay. Now, one way we could do this graphically is, so to get to m to a, we have to go over 4 and down 2. So it has to be the same on both sides, right? So if you go over 4, 2, 3, 4, and down 2, we get to y. Now, if you choose to do this graphically, then you need to actually show in your graph how you end up with y. Okay. So those are two different ways of doing it. All right, so let's go to the next part. This question keeps going. All right, so we have to prove myth is a rectangle. So remember, a rectangle is a parallelogram with at least one right angle. Okay, so we first have to prove that is a parallelogram. Then we have to go a step further and show either there's a 90-degree angle or the diagonals are congruent. Okay, so remember we talked about the 4 different ways of proving that is a parallelogram is a parallelogram. Now, one of those ways is showing that the all opposite sides are parallel, so opposite slopes are equal. Now that's going to help us kind of prove that there's a right angle, right, with perpendicular lines. So I suggest we kind of go that route, so doing slope 4 times. Okay, so looking at my thing here, I have to do the slope of MH, HT, TY, and MY. Okay. Slope of MY and the slope of HT. Now here's the thing, we actually did slopes here. So we did the slope of TH, which is -1/2. So probably don't have to do it again. But we should do the slopes of these 3 again. So MH, so the coordinates of M is -1, 7, and H is -6, -3. Now be careful of the coordinates, right? So the slope of MH is -3 minus 7 over -6 minus -1. So this is -10 over -5, which is 2. Now we got y is 7, 3 and t is 2, -7. So yt is -7 minus 3, and then 2 minus 7. So you get 2. My. M is, so 7 minus 3 over 7. No. What did I use? So 7, -1 minus 7. So we get 4 over -8, which is -1 over 2. Okay? So here we have opposite sides are parallel, slopes are equal. Opposite sides are parallel, slopes are equal. Okay, so now we need a statement. Now, like I said, hold on one second. Before we do that, I just want to talk about this for a second. So we proved that it's a parallelogram. Now we also showed that we have a 90-degree angle because these two slopes are negative reciprocals of each other. So that shows that these two lines are perpendicular. So that shows that there's a right angle. Okay. So the last thing we need, like I was getting to before I stopped myself, is a statement. Okay. So our statement can be myth is a rectangle because opposite sides are parallel and angle H is a right angle because MH is perpendicular to HT. Now this does, remember, your statements do not need to be fancy. They don't need to be complicated. They just need to state what you're trying to prove and summarize, your work that you have here.